This is Ron Follett, and I'm presenting information about CAS Task Force Report number 142. My name is Ronald Follett. The title of the CAS report is Carbon Sequestration and Greenhouse Gas Fluxes in Agriculture, Challenges and Opportunities. This report was pulled together by myself and three other co-chairs, Sean Mooney, Jack Morgan, and Keith Postian, as well as 18 other authors, all of who contributed different sections to the report. What we're talking about in this slide is climate change and agriculture, and it's very well recognized that scientists over the long period of time have been able to measure how much radiation is coming in from the sun, how much is reflected by clouds or reflected from the Earth's surface, and also to recognize and know how much is being reflected back from the Earth's surface as well. And one of the things that we're interested in here are greenhouse gases, which I've highlighted, and these have been measured as how much there are of them and how much back radiation they provide to the Earth's surface. Now, greenhouse gases are important, and I want you to consider the fact that if they were too low, the Earth would be much cooler, or too high, then it can get warmer. If they were too low, they do have a mean warming effect of about 33 degrees centigrade or 59 degrees Fahrenheit. This makes life on this planet possible, and humans are contributing to increased atmospheric greenhouse gas concentrations. And Earth's energy balance is being altered, and thus the planet is warming. These two slides, the one on the left, shows how greenhouse gases that are important to agriculture have been increasing for the last 2,000 years. And as you can see, following the Industrial Revolution of about 1750, they've all been increasing, and they're increasing very dramatically. On the right, we have a graph that shows the increases in annual global surface temperature over both oceans and land since 1880. The red bars indicate temperatures above, and the blue bars represent temperatures below the average temperature period from 1901 to 2000. And the black line is atmospheric CO2, so you can see there is a high correlation to the carbon dioxide in the atmosphere. Now, these two graphs, and the one on the top is under a high emission scenario, the one on the left and one on the right top, and on the bottom is a low emission scenario. And the little thermometers then indicate that under a high emission scenario by 2040 to 2059, the temperature may be close to 5 degrees Fahrenheit warmer, and by the end of the century could be as much as 9 or 10 degrees warmer, and under the low scenario it would be about 4 degrees by 2040 to 2059, and under the high scenario it could be about up warmer. This shows the precipitation patterns that might be expected, and if you look at again the winter, spring, summer, and fall by 2089, you'll see the blue indicating much wetter areas at the higher latitudes, and the brown being much drier. And particularly in the winter and spring, this is true. By summer, much of the United States is drier, with Canada being wetter, and then by fall, the midsection of the United States would be dry. An uncertain and changing future climate indicates that we're going to have increased incidence of extreme weather, warmer temperatures, retreating glaciers, thawing permafrost, and pest infestation. Consequences that are likely to differ regionally in severity, and increased future drought predicted in some parts of the United States, and significant increase or decrease in rainfall quantity, timing, and intensity in the United States. So climate change challenges agriculture then to adapt its management and land use to the changing climate, adopt mitigation strategies to decrease agriculture's net greenhouse gas emissions, continue its important role to produce food, feed, fiber, and fuel required for the world's growing population, and provide for conservation and protect the United States natural resources. This particular graph is important in that it shows the changes between 1990 to 2009, with the bars below the line meaning carbon sequestration and the removal of greenhouse gases from the atmosphere, and those above the line indicating emissions to the atmosphere. And so nitrous oxide, a greenhouse gas, are the ones shown in gray, the ones just above the line, whereas those that are blue, purple, and red are from livestock, from their enteric fermentation or manure. And then we move on up to fossil fuel use by agriculture itself, which hasn't been changing much, and then smaller quantities due to rice and liming and other practices. Now this graph illustrates some of the greenhouse gas emission sources associated with agricultural activities. And certainly land clearing is one of them that can emit CO2, although it does release litter that can go into sequestered carbon in the soil. And fire from burning livestock can emit methane, and manures can release nitrous oxide. And then we've got our mechanical operations such as tillage and use of fertilizers and so forth that can emit other gas fare. So the mitigation options for agriculture are by sequestering carbon in biomass and in the soils to reduce result in a net removal of carbon dioxide from the atmosphere, decreasing emissions of greenhouse gases, and sustainable agricultural biofuels present a third mitigation category with the potential to offset CO2 emissions from fossil fuels. This would be ideal, this particular graph, where we would start on the left, and that would have been the amount of carbon in the soil at the time it was broken from its native condition and cultivated. After cultivation, then, the quantities of carbon go down and steadily decrease slowly, and we're now where we want to make a management change over here on the right-hand side of the graph, and to begin to replace that soil carbon through improved cultural practices. Now, in terms of sequestering soil carbon on cropland, there are several things that can be done. No tillage, conservation tillage, use of cover crops, additions of manures, reduced bare fallow, other practices, including irrigation of fertility, re-wetting and flooding organic soils, tree planting on cropland. Under grazing lands, stocking rates is important. Grazing method can be important. Prescribed fire, improvement of degraded rangelands, and pasture management are. Now, one of the mitigation options is called agroforestry, or the growing of trees, working trees on cropland, in which the trees contribute to the farm operation, either by providing shelter, serving as a windbreak, and catching eroded sediments and deposition on the ground. The trees also serve as soil carbon sinks, or carbon in their tops or in their wood, and then they reduce emissions, and they shelter crops so that there's potential for better crop yields and more soil carbon sequestration under the crop. Other important practices, such as for horticulture crops, can include drip irrigation and cover crop management to reduce emissions, wetland agriculture, avoid incorporating fresh residues, split applications of nitrogen, and use of inhibitors to minimize nitrous oxide emissions, and then various other agricultural lands, such as the Conservation Reserve Program, or CRP, which after 20 years has significantly reduced soil erosion, restored wetlands and buffers, sequestered millions of tons of carbon dioxide, and enhanced wildlife habitat. Confined livestock, the options there, and we're dealing then with ruminants such as cattle, sheep, and goats. They produce methane as a byproduct of their digestion. The options to decrease enteric methane emissions include improving their diet, food additives or dietary additives and improve livestock genetics. Livestock manure can emit methane and nitrous oxide during storage and alter field application. Options to decrease emissions from manure include methane capture from covered legumes, manure cooling, and best management practices for field application. Bioenergy feedstocks are another important opportunity for U.S. agriculture to help mitigate climate change, such as by sequestering carbon in soils, lowering nitrous oxide emissions compared to grain-based systems. Now, looking at various systems of bioenergy feedstock production, where the bars are below the line, it means that they're reducing the total amount of greenhouse gas emissions to the atmosphere. Those above mean that it is an emission to the atmosphere. And corn soybean conservation till is the first blue line, followed by the red, which is again conservation tillage. And you can see that for soil organic carbon, the red increases emissions of both CO2 and N2O and the soil greenhouse gas budget. The switchgrass, which is shown in black, would reduce emissions overall. Long phase corn soybean no-till, where they're using no-till, is much less than the conventional till, and certainly miscanthus is another potential. Now, economics is critical in adoption of greenhouse gas emissions and practices to lower the emissions. Some producers in the United States already have adopted and found such practices profitable. Broader adaptation will require practices to become profitable to more producers or from their response to regulatory mandates. Policy design can include taxes and cap-and-trade policies. Under taxes, emitters of greenhouse gases would be taxed on their emissions, and some of the issues include what would be taxed. For example, a tax on fossil fuels would not fully encourage many agricultural practices like soil carbon sequestration. Taxes on fertilizer and equipment might incentivize land use change. Taxes on bioenergy inputs such as fertilizer and fossil fuels might discourage such carbon sequestering practices, and revenues that accrue to the public sector may or may not be used to decrease greenhouse. On the other hand, policy design based on cap-and-trade policies would require then overall limit or cap on emissions to be set by a regulatory system. And in some systems and non-regulated entities, such as agriculture, might not be required to be capped, and they could also generate offsets where they would get paid for offsetting other people's emissions. Items that trade reflect reductions in greenhouse gas emissions and are referred to as carbon credits. They, however, typically are assumed to cover all greenhouse gases, and in contrast to the tax system, revenues here accrue to private sector and may encourage better innovation. Implementation and policy issues. In 1994, the United States and many other countries joined the United Nations Framework Convention on Climate Change to address global warming and its consequences. Signatory nations agreed to report their national greenhouse gas emissions annually to the United Nations Framework Convention on Climate Change, the UNFCCC, using agreed-on counting methodologies developed by the Intergovernmental Panel on Climate. Now, implementation and policy issues. Soils in some states of the Corn Belt and Great Plains are CO2 sinks, while Florida, Texas, and Minnesota are sources. So this can be developed in terms of maps to know just where policy changes may be most important and where emissions are most prevalent in terms of the United States and by various. So in conclusion, there are numerous opportunities for U.S. agriculture to mitigate greenhouse gas emissions. Bioenergy crops offer important opportunities. Incentives may be needed and can be used to increase the number of producers that adopt. With that, I thank you for your time.